Hi, I'm Xintong Li. I'm glad to present our work on self-training for conversational neural NLG. Most neural models require large quantities of data to obtain good performance. Constraint decoding with compositional input is nearly always correct, but too slow to deploy in task-oriented dialog system. Thus, finding ways to improve data efficiency for training models that perform satisfactorily with vanilla decoding is important. This is an example of compositional meaning representation and annotated response from conversational Viola dataset. Here, the bracketing tokens are non-terminals, which offer greater control over the expression of discourse relations and lead to improvements in semantic correctness. Tree accuracy is the ratio of annotated response that has the same non-terminal tree structure with the input meaning representation. Self-training has been shown to help with the data efficiency. We examine whether constraint decoding can improve the self-training. We also compare to use the reverse model for rescoring in self-training. This figure shows the comparisons among 4 training strategies on tree accuracy and BLEU scores as a function of the amount of parallel data available. We can clearly see that constraint decoding self-training always surpasses the other 3 training methods. Meanwhile, the green lines are much flatter, indicating better data efficiency, especially for tree accuracy with less parallel data. In particular, it even achieves a considerable tree accuracy of 90% using only 1% of parallel data. Using 100% of the data, it sets a new state-of-the-art in both tree accuracy and BLEU score. Perhaps most notably, with vanilla decoding, it needs only 20% of parallel data to achieve comparable performance to the base model trained on all the parallel data. This is a key result, since vanilla decoding is so much faster than constraint decoding, and latency is an important consideration for dialog systems. The McNemar's test confirmed the gains of constraint decoding self-training are highly significant. We also asked 2 linguists to judge correctness and fluency of the models. The evaluation shows the self-training models was judged significantly better on correctness and slightly worse on fluency. The most frequent fluency issue was missing punctuation between independent clauses, and the correctness errors usually involved missing information, but sometimes also repeated or extra information. In conclusion, we have shown that using self-training with constraint decoding and reverse model re-ranking in compositional neural NLG can deliver large gains in data efficiency, enabling simple and faster sequence-to-sequence model to achieve satisfactory quality with much less annotated data. The code will be public on GitHub. Thank you for your attention.